No mozzies with that stuff. Okay, so we have here.
Yeah, okay.
Yeah.
But are you going to actually be able to concentrate while you're filming? Because you're concentrating on the filming.
I'll put it here and I'll listen. I won't concentrate on the filming. Okay, go.
So, okay. It's a very simple thing. So, this is your magnets, eh? Right? Your south, your north, whatever. This is...
Wait, why is south and north relevant to the alternator and the engine?
I'm just saying like a magnet has north and south pole. I was just doing
right.
it to say it's a magnet. It's no big deal.
That's the battery.
No,
That's the alternator. Okay.
No. This is just... I'm just trying to explain how an electrical current is produced using a magnet and mechanical movement, which is the concept of an alternator.
Which is also the same as the hydroelectricity.
Yep. Yeah. Like just to produce electricity via mechanical movement using magnets.
Okay.
Okay. So this is your wire. So your copper wire comes in here, and then there's heaps of copper. Like
comes into the magnet.
Yeah. So it's inside. This is like.
Sorry, and the copper wires are coming from the engine to the magnet, which is in the alternator.
We're just getting too ahead because I'm just trying to explain like the basic concept, and then maybe if we can say, okay, that's how an alternator works. And
okay. So this is just So
this is explaining how current is made.
Okay.
Right?
Yes.
And this is the foundation of these things. So this is the wire, your copper wire. In here, dook, and then out. This is the copper wire going within the magnetic field. Okay? So if this is spun around like this, so imagine this was 3D, and it's like this is the wire spinning.
Wait, sorry. Magnetic field is created with maybe like a magnet and another magnet next to it. Okay. That's like positive and positive, or negative and negative, like where it's pushing against like the pressure. Or it's actually
one end's
connected?
just one end's one end's north, one end's south.
Which means
like the overall, like there'll probably be a few magnets.
Yeah.
Okay.
Okay. Yeah.
But this is just like this is north, this is south of a magnet, right? And so they're here, and this is creating a field in between them, the magnetic field. Okay.
Yeah.
Right.
Yes. Gotcha.
Yep. So this is the wire coming in. Now it's within the field, and then it comes out. So if this wire is spun like this, within this field, it'll produce an electric current.
So there's a wire in between the two copper wires?
No, this is the copper wires.
Okay.
Just imagine this is the two wires.
That are like now connected. So so it looks like here you've got a copper wire bringing something in, and then a copper wire bringing something out.
Yes.
And those two are like in this space between entering the magnet and exiting the magnet. Are they charging each other?
No, it's just like, this is just the wire that makes a circuit doing two other things, right? Yep. It'll probably come to a battery or whatever.
Yeah. Okay.
But just imagine these are the wires, all right? Yeah. They're together, whatever. All right? There's a mechanical force that's making these spin around the wire, okay? If you have a wire spinning inside a magnetic field, it'll cause something called like a flux. I can't explain what that means really, but it's like there's like directions, like there's some hand tricks you do to like know which way the direction of like the flux will be, but forget about that. So just understand, if there's a wire coming in within a magnetic field, if that spins around, it's been spun mechanically, that will produce a current within the wire. Okay? And then that current now being produced will go to a battery to be stored.
Yeah.
Okay? And then the battery will store the electricity, the current being the electricity.
Sure. How does it decide where, like, how does the energy not go back out through the other wire?
Because energy has a direction. Like electricity goes in a direction. So depending on what...
Like a river.
Yeah.
This is why it's like the water system.
Depending on what way the north and south is, it's like you do some hand thing. I think it's like you follow the wire and you wrap it around, and that's the direction of the flux.
Okay, so this looks a lot like a water wheel. Can we talk about?
It's not. This is not nothing.
Yeah. So the magnet is the river, for example, and then the river's going down south, and then this coming. Well, it says coming from the south. It's going north. No, yeah, we'll go north. Yeah, north south, because then this water's pushing the energy, like it's coming down. I don't know that. Okay, no, this is the river, and down the river from north, hits the wheel. The wheel's spinning, and then it goes south to. Oh no, I don't know how that works.
No, I think I get what you're saying, but I think you're getting mixed up with how it's working.
Okay, which is cool
because
it's not exactly the same as how the hydro.
River. No, well, it's used. This hydro uses this concept. So say this is a river here, the river flowing.
Yeah.
And there's a wheel here, and it's spinning that wheel.
Yeah.
That wheel is connected to this. So that river is providing the mechanical movement, right? The movement of the wheel. Mm-hmm. The wheel is then connected to the copper wires that comes out within a magnetic field. Oh. So that spinning within a field creates an electrical current within the wire. And that current will flow in a certain way depending on the position within the north and south. That current will then flow to a battery to be stored, or it'll just flow basically while the wheel is moving, and this is moving in the flux of the field.
Yeah, an energy current is being created.
And energy current is being created. Yeah. As soon as it stops moving, the current will stop.
So, go back to it being a car.
Yes.
And where's this electrical current coming from then?
So, with a car, it's
the engine. Wire, where's it getting it? It's getting it from the engine.
The engine is creating the mechanical movement.
Yeah.
Right?
Like the
water wheel, but now we've got the combustible engine creating the movement.
Yeah.
So that is connected to wires. And it'll be a bit different than this. Is just a basic explanation.
Yeah, yeah.
So that's creating the movement.
Yeah.
Right? And then that's connected to the wire that's within the field. And so whilst that's moving...
Is this the alternator now?
Yes.
Okay, so the alternator was the magnet in the...
The alternator is the whole thing.
Example.
No, the alternator is the whole thing. Like this thing is the alternator.
I know, but when you were using the example of the energy current coming down, going to a magnetic field, and then leaving the energy current, that in this analogy is the engine taking the energy from the engine through the copper wire down to the alternator, and then from the alternator out towards the battery.
Sort of, not quite. So it's not that the energy is coming down the wire like that from the motor. It's that movement and the copper wire moving in a field generates an electrical current.
So it's a bit more complex. There's also energy coming from the diesel of the engine. It's not just a wheel moving. It's diesel that's being burnt that's creating the fire that is moving something else, like the wheel, to then move the energy.
The engine is creating the movement that you need to generate a current.
And how is the engine creating energy? Burning the diesel?
Yeah, it's like how the concept of how a motor works.
Yeah, what's the concept of how a motor works? Or you don't want to go into that? We'll focus on this.
Yeah, because I can't explain it as well.
Okay.
But just say the motor produces the motor works to create a mechanical movement to drive your wheels. Like you ride your bike, you create your feet. You are the motor.
Yeah.
Creating the movement of the wheel.
Yeah.
So.
Okay. There's essentially a wheel in the engine, but it's not a wheel. It's a big.
It's just a rotation energy.
Yeah.
Like, I'm just saying, using the word energy is.
Electricity.
No,
power.
I'm not. I'm just using. Everything has energy.
Power.
I suppose.
Somewhat.
Yeah, just a movement. Like, and that movement is connected to this, which is rotating within a field. And if there's a copper wire, like connected like a circuit, moving in a magnetic field, it'll generate electricity within that wire. Does that make sense?
I just zoned out, but that's okay. You've done well. So anyway, this is the alternator that's being powered by the engine, and what does the alternator do?
So the alternator,
it's moving like a fan.
Yeah, so it's like the wire in there is getting rotated within the field from the engine, right? So the engine's driving the wheels. Yeah. The wheels spin around. Yeah.
Yeah.
Also on the engine, there's the alternator.
Yeah.
And within that alternator is this concept, like the whole.
yeah.
Okay.
Yeah. Okay. Cool.
And the movement, the engine is making the movement, the circular movement of the wires, and this is the alternator. And so because it creates, if you're moving wires within a magnetic field, it creates a current, electricity. And so then that electricity charges the battery.
Yep.
And so then you're storing the energy. If you didn't have a battery, the energy wouldn't be stored. It would be created in the moment. So you could run a light off it. If you put a light in that circuit, it would light up while it's rotating. But then once it stops, the energy won't be there because there's nothing moving. Where did it go? Well, from the engine. You need something to be rotating the wire, right? To create the electricity within a magnetic. Yeah,
but if the energy wasn't going to a battery,
it just wouldn't be there.
Yeah. Okay. Yeah. Okay. That's the
because
storing. I get
to
that
go
now.
further within a wire, like a metal, like copper. Yeah. If you want to get down to it, electricity is the movement of electrons. Okay. So a wire, metal, is actually how it's composed is like a bunch of the electrons within the structure are free, like they're free to move. So the electricity is just the movement of electrons. So this rotating within the field causes those electrons to move. And when electrons move, that is an electrical current. And that's how you create electricity. So those electrons move through a light that's in that circuit and it'll cause it to light up. Once it stops, the electrons have stopped moving. They're still within the thing because they're all part of the thing. And then there's no current produced. It's sort of getting hard to concentrate because the bugs are getting louder.
Yeah, it's quite nice though.
It is nice.
But what are we doing?
I think I'm
ready to go.
Yeah, but are you sort of getting there a little bit?
Yeah. I just am now trying to apply this to the bush garden.
We came from what?
Wait, I just need it.
We came from electrical.
Now if Tom dies, I know how the car works. This is going on my channel.